your all's questions first, and then with extra time, I'll pull in some additional review to make sure we're prepared. So number 16, we are solving these log equations. So we have the natural log of x minus 1 minus the natural log of x plus 6 equals natural log of x minus 2 minus natural log of x plus 3. Okay, properties of logs. We know that it's legal to add a log to both sides of the equation, which means it's legal to take it away from both sides. However, for that to work, you can only have one log on each side. So first, I have to combine these. If those logs are subtracted, how do we put them together? Division. Now, when you do that, it's not natural log of the first over the natural log of the second. There's a natural log out in front, and then it's the x minus 1 over x plus 6. So there's only one log written. So same thing here. These are subtracted, so I put them together, and we are divided. So now if we have a log on each side, we can drop that. So then if we cross multiply, we have to FOIL. So we get x squared plus 3x and minus 1x. So plus 2x minus 3. And this one, we get x squared plus 4x minus 12. Right? If I subtract over my x squared, those drop. If I subtract my 4x and negative 2x and add my 3 equals negative 9. So divide, and we get a positive 9 over 2. Now remember, on these problems with logs, we always need to check our answer. When you check, you are looking to make sure that every argument is greater than 0 when you plug it in. So if I have 9 halves, that's 4.5. So if I put in 4.5, all of those are positives, so it's okay. That would be our final answer. You guys sure there weren't any other of those exponential or log equations you need to work out? 18. How many years will it take? So I'm looking for the time. For an initial investment of $25,000, so that's what I'm starting with, so that's my P. To grow to 80,000, so I'm ending with 80,000, that's my A. Assume the interest rate is 7%, compounded continuously, so that's what tells me it's A equals PE to the RT when I say that continuous interest.
You'll give us the formula.
Yes, I will give you those interest formulas. So the A is 80,000.
Will you give us those formulas, or will let me finish?
Let me finish!
And disclose what they're for, or is you just giving us the formula?
I would just give you the formula. You'd have to be so probably very similar to how I put it on your study guide, just in parentheses afterwards. And you just have to know how to use the variables. So first step here would be what? Divide. We're trying to get to the T, so we have to get rid of this 25,000. All right, 80,000 divided by 20,000, or 25,000. Okay, if I'm trying to solve for T, what do I do next? Okay, a few people had some confusion yesterday with what's happening here. A natural log of E is 1, but right now this is not the natural log of E. It's the natural log of E to a power. So you have to use your properties of logs last year. That exponent comes down in front. And then you have a natural log of E, which becomes 1. So we get the natural log of 3.2 equals 0.07t times 1, which is just 0.07t. So then we divide. So we've got natural log 3.2 divided by 0.07. And that gives us 16.616. I think I said 16.6 years.
Question.
Mm-hmm.
Just make it easier for myself. Is the big number always go like in where T is, or on the T?
It should be the A is going to be bigger. If we're talking about interest,
That's
you
what
should.
I meant. Yeah, that's what I meant.
Are we gonna have a decay or a decay question?
I could.
We didn't have one.
Yeah, it's all using a similar type of equation. It's just in that case, with exponential decay,
I was just
the variables are different, but the same setup as this, so your exponent would be negative, so you would end with a smaller amount than your starting point.
No.
Yes.
Yeah, I don't need your
It
help
wouldn't
either,
make
Friday.
any difference if like who just cancels the natural log, so you wouldn't.
As long as you didn't do it, the problem I saw with a few people yesterday is they were canceling it here and then saying it was 1 to the 0.07t, and that's wrong.
Right, okay.
So as long as you bring down your exponent, then you're okay. Other questions?
I'm assuming.
You weren't alone. Okay, number 19. Find the doubling time. So we're looking for time again. Of an investment compounded semi-annually, so the number of times a year would be 2. My rate is 0.03. And I gave you the compound interest formula, but you'll notice we don't have all of these variables. So what do I know? It's doubling time. It has to double. Okay, you just make up an amount. If you start with 1, then you end with 2. You could, if you start with 100, you end with 200, or 1,000 and 2,000. It doesn't matter as long as you double it. So then if I plug those in, okay, if you did something other than 1 and 2, you would need to divide that over right now. That would just give you a 2 here. Then 1 plus 0.03 divided by 2.
No matter what you do, you always get.
Alright, now what? Now we can add a log on each side. So, properties of logs, the exponent comes down. So if I'm trying to get t by itself, I have to divide by the 2 and the log 1.015. On your test, I really encourage you to make sure you show this work so that way if you do put it in your calculator wrong, I know what you were putting in and that it was just a calculator error, not that you solved the problem wrong. So if I put that in, we get 23.278 or 23.3 years.
Are we going to Zoom and steal all of our snacks when she gets home?
So, problem 20, we just needed B, is that correct? Okay, we have to break this apart. We know that if things are multiplied together, we add their logs. So that's the natural log of 3 plus the natural log of x. When things are divided, we subtract. So minus the natural log of x cubed minus 1. Can you break apart this x cubed minus 1? No, we can break apart multiplication and division, not addition and subtraction. So we can't do anything with that. Can I bring down that cube?
Probably not.
No, because it's not the entire thing that's cubed. So if the cube were out here, then it would be okay to drop it down in front, but because it's only on the x, and I can't separate the x and the 1, I just have to leave it alone. So that is my final answer. You could factor using difference of cubes and then break apart a little more. But. So you guys remember the domain on 22?
Mm-hmm.
Just your argument greater than 0.
Mm-hmm.
Alright, 23. I gave you the pH equation, which I would on the test as well. You don't have to memorize that, you just have to be able to use it. So on part A, it says to find the pH, and it tells you H3O plus is 1.8 times 10 to the negative 4. So all you're doing is plugging that into your equation. So we have negative log 1.8 times 10 to the negative 4. If I go to my calculator and put that in, we typically just did one decimal place for pH. So we get a pH of 3.7.
How many years problems will you take off of the
On B, this time it gave us the pH. It was 8.6. So in our equation, we are plugging that in for the pH. Let's say 8.6 equals negative log H3O plus. So I'm trying to solve for the H3O plus here. What do we do? Have to move that negative over, so if you divide by negative 1 on each side. Okay. When there's a log on each side, we can just drop them. If there's only a log on one side, how do you get rid of it? We change it to exponential form. So the base of this log is 10. So it's 10 to the negative 8.6 power equals H3O plus. So if you plug 10 to the negative 8.6 on your calculator, it gives you 2.511886432, and then at the end it says E negative 9. So remember we wrote that in scientific notation. So we just rounded 2.5. This E means times negative 9, 10 to the negative 9. Hmm? Let's look at 25. So C.
Yes.
We said log base 10 0.01. How do you read 0.01? 100. So that is the same as 1 over 100. So you can make this an equation if you need to, or you can ask yourself, this just means 10 to what power equals 1 over 100? Or if you set it equal to x, you could say that means 10 to the x equals 1 over 100. Common base. So 10 to what power is 1 over 100? The negative is what flips it, and 10 squared is 100. On F, you probably were not able to just look at that and say, okay, 3 to what power equals 27 to the 3 halves. But we could set it up as an equation and solve it. If we set this equal to x, that says 3 to the x power equals 27 to the 3 halves. Common base. 27 is
3 to the third.
Why are we so much more sensitive?
power to a power. What do we do with those? So then it's the same base, you can drop them, so your x is 9 halves.
That makes it so much easier.
Good. You could.
Gosh, that makes it so easy when teachers do. Good.
She never says yes or no. It's always we could.
Yeah, man.
At least you don't say, when you're asking help on a test, you don't say, well, I think you're on the right track. Don't say I think. Just tell me if I'm doing the right thing.
I just said.
All
right.
Over 1. You just multiply.
No.
That's a lot of extra work, bro.
So, if there's only a log on one side, what do we do?
Exponential.
10/3.
So, if we 4 to the 7x minus 1 equals 64.
Goes 4 to the third.
Okay, 64 is 4 to the third, so we have a common base. So you can say 7x minus 1 equals 3. So add your 1, divide by 7, and you get 4 sevenths. Is that one okay?
Yeah.
Alright, number 2. First, we have 2 logs added. So what do? Multiply the arguments. So that's 13x minus 3x squared. We only have a log on one side. How do we get rid of it?
That 10, boy, that 10 to the first.
Exponential. It's now just like problem 1. If there's no base of a log, it's 10. So 10 to the first equals 13x minus 3x squared. I'm going to move everything over so my square term is positive. So 3x squared minus 13x plus 10. You can do slip and slide. So you get x minus 10, x minus 3. You have to divide those by 3. So 3x minus 10 and x minus 1.
Every day 10 things in 1.
And what else do you have to check?
You gotta check that 1, man.
That the arguments are positive. Okay, so we can put in a 10/3 to both. We can put a 1 into both. So
Why
Yeah.
did the negative change come down?
What?
From 13, it was on -3.
I moved everything over to the side. I added my 3x squared over and subtracted my 13x. Other questions?
No.
Number 3. These two are both logs, but this one isn't. So what'd you do? I put all the logs on one side. If logs are subtracted, how do you combine them? And then if there's only a log on one side, what do we do? 7 to the first equals 3x plus 2 over x minus 2. So we can multiply over the x minus 2. 7 to the first is just 7, so we get 7x minus 14 equals 3x plus 2. Subtract over your 3x, add your 14, and we get 4. Double check, when you put 4 in, both arguments are positive, so that's okay. Number 4, what do we do? So, a couple options. If I just work as it is, everything has a log. So we just need to combine to 1 on each side. Those are subtracted, so you would divide. And then if you have 1 log on each side, you can drop them. multiply the x plus 1 over. We get 6x equals 4x plus 4. Subtract the 4x, divide by 2. Double check, 6 times 2 is positive, 6 plus 1 is positive, so that's okay.
Last time it couldn't go.
I want to do a few exponentials.
Oh, you freaking kidding me, guy.
Do you really want to complain? I'm helping you prepare for a test tomorrow. It's not like I'm giving you homework. I'm asking you to do something in class. Alright, here we go.
Good God.
On 5 to break apart. We have to break apart our x and y.
I'm on 6.
So, what would we do on 5?
Put it in log form.
Yep, since it's an e, we typically do the natural log. Okay, exponent comes down, but what's the natural log of e?
1.
So that just goes away. So then to get your x by itself, you can subtract the 4 and then divide by -7. So you have the natural log of 5 minus 4 all over -7.
0.3415.
Thank you. 3415. Okay. On number 6, what do we do?
Put it in log.
Yep, add a log to each side. And when you do that, your exponent comes down in front. Okay, because this exponent had 2 terms, we have to distribute. So we get 2 log 5 minus 3x log 5. What should you do now?
Combine
All the
them.
x's on the same side.
Oh, yes.
Both of these have an x in them, so we would and then to get x by itself, you divide. So you have 2 log 5 divided by log 6 plus 3 log 5. So if you put that in, you have 0.4862. Okay, those are probably the longest problems that we have right there. Number 7. We've had some of these on the homework and it seemed to give people problems because they wanted to multiply the 2 and the 3.
Find that 2 over.
But order of operations says you can't, so instead you have to divide the 2. So we get 3 to the 0.4x equals 7 over 2. Then what do you do?
Depending on the third log.
So you get 0.4x log 3 equals the log of 7 over 2. So then to get x by itself, you're just dividing by everything. So you have log of 7 over 2 divided by 0.4 log 3. 6.85, you said? Alright. And the last one, change of base. You have to show me the work on this. So what do you do?
1/7 divided by 1/5. It's like 1 point something.
1.2099.
Log of the argument over the log of the base. So, test tomorrow. If you need more review or have any questions, please see me.